Hello students, Applied Mechanics AME. In previous lectures, we have already seen the problems on the topic simple lifting machines. In today's lecture, we are going to solve the problems on different types of simple machines, that is the remaining problems on simple machines. Before starting the problems, we want to list out all the formulas that require to solve these problems. The formula for mechanical advantage, percentage efficiency, effort loss in friction and load loss in friction. Also, in addition of these formulas, there is a formulas of velocity ratio are required for different types of simple motions. Okay. Okay. Let's come towards the first problem. In worm and worm wheel, the number of teeth on the worm wheel is 120. The diameter of the effort wheel is 100 mm and that of loading drum is 150 mm. This worm wheels lifts a load of 2.5 kN by applying 100 Newton effort. Calculate efficiency and effort loss in friction. This example is asked for exam winter 2019. Okay, students, see here the image of worm and worm wheel. In the middle portion of the image there is a two worms, that is two gear setters are there on which the rope is wounded, and at the end of this rope there is a load. The load is carried by this worm wheel. At the right side of the machine there is a effort wheel. On this effort wheel there is a effort is there. Okay, then move towards the given data which is given in this question. The number of teeth in the worm wheel T is equal to 120. That is, on the worm wheel there is number of teeth are there, and these numbers are 120. Then they give the radius of effort wheel capital R, that is there is a effort wheel. Here in this question they give the diameter of the effort wheel 100 mm, but we want calculate the radius. The radius R is equal to D by 2, that is diameter divided by 2, and it is equal to 50 mm. Then they have also given the radius of load drum small r. Also they give the the loading drum diameter is 150 mm, but we want the radius, and it is equal to the small d divided by 2, that is 150 divided by 2, and it is equal to 75 mm. Then they give the load W is equal to 2.5 kN, and it is equal to in Newton is 2500 Newton, and also they give the effort 100 Newton. Okay, and we want to calculate here the percentage efficiency and the effort loss in friction in this machine. Okay, first we calculate the efficiency of machine. To calculate the efficiency of machine, first we want to calculate the mechanical advantage, and the formula for mechanical advantage is equal to W upon P. We have the value of W 2500 and the effort is 100. Then by solving we get the value of mechanical advantage is 25. Then second, we want to calculate the velocity ratio, and the formula for velocity ratio for this machine is capital RT divided by small r. That is, capital R means the radius of effort wheel and small r means the radius of load drum. The values are given, that is 50 into 120 divided by 75. Then by solving we get the value of velocity ratio is 80. Then the efficiency, we know the formula for efficiency is equal to MA upon VR into 100. Then by putting these values of MA and VR and by solving we get the efficiency percentage. Efficiency is equal to 31.25%. And this is one of the answer of our question. Then they want to calculate the effort loss in friction, and the formula for effort loss in friction is Pf is equal to P minus Pi. Then Pi means ideal effort, that is the formula is W minus W upon V upon R. Then Pf, the values of putting the values of P, W and VR, and by solving we get the value of Pf, that is effort loss in friction is 68.75 Newton, and this is the second answer of our question, and here the problems are over. Then second problem. The second problem is on double purchase cramp. A double purchase cramp used in a laboratory has following details: diameter of load drum 160 mm, length of handle 360 mm, number of teeth on pinion 20 and 30, number of teeth on spool wheel 75 and 90. When tested, it was found that an effort of 90 Newton was required to lift a load of 1800 Newton, and effort of 135 Newton was required to lift a load of 3150 Newton. Then determine law of machine, and second, portable effort to lift load of 4500 Newton. Okay, this example is asked for exam winter 2017. Okay, this is the image of double purchase cramp. We can see at the middle of this image there is a load drum on which there is a rope is wounded. On the end of the rope there is a load is there. The load drum having the diameter is small d. At the side of this load drum there is a two gear set, that is spool wheel A and spool wheel C. This is on the upside of there is a pinion B and pinion D, on which there is a T1, T2, T3 and T4 are there. Means the number of teeth on these spool wheel and pinion wheels are there. At the side there is a effort wheel on which the effort is applied. Also, instead of effort wheel there is a handle is provided. Okay, then come towards the given data which are given in this question. There is a N1 is equal to 75 and N2 is 20. N1 means the number of teeth on spool wheel and N2 means the number of teeth on pinion wheels. T3 is equal to 90 and N3 is equal to 90 and N4 is 30. That is, N3 means number of teeth on spool wheel and N4 is number of teeth on pinion. N1, N2, N3, N4 is same, that is T1, T2, T4, T3. Okay. Then here the handle length is provided. In some time there is a effort wheel is provided and that time the diameter is given, but here now the length of handle is provided, it is 360 mm. Small d is 160 mm, that is load diameter of load drum. When effort is P is equal to 90 mm to lift a W of 1800, and second P is equal to 135 Newton to lift a load of 3150 Newton. Then we have to calculate the law of machine, and effort P when to lift the load of 4500 Newton. Okay, first calculate the law of machine. The law of machine is P is equal to mw plus c. Then put the values of efforts and load. First, the effort P is equal to 90 mm is equal to mw, that is 1800 plus c, that is it becomes equation number 1. Then second, put the values of P 135 is equal to m into w 3150 plus c, this equation number 2. Then by solving, that is by subtracting equation 1 from equation 2, we get the value of m, and m is equal to 0.033. Okay, then put this value of m in equation number 1, then we get, or by solving we get the value of c is 30.6. okay, we get value of m and c. Put this value in law of motion equation, and we get the law of motion is P is equal to 0.033 into W plus 30.6, and this is the equation of law of motion. Okay, this is the one of the answer of our question. Only write the value of m and W, keep as it is the value of P and W. Okay, then they ask what is the effort when the load is 4500. Then put the value of load W 4500 in above equation. Then by solving we get the effort, that is P is equal to 179.1 Newton, and this is the second answer of our question. Here all the problems are over. Thank you.